those variables, can simulate it before you actually build the product, right? And again, if you see on the right side, there is actually a roulette, right? So simulation models can also be used in casinos, right? So this is used by casinos to figure out whether how much money will they make. For example, in this case, so there is, if you can see on the top right, there is a green, right? So when you actually throw that die or the ball, if it actually falls on that green, that means you actually do not get the money. In Europe, there is only one green, but whereas in US there are two greens. So it actually tilts when there are two greens, number of possibilities increase. It tilts the favor in terms of the casino, right? So simulation problem is mostly to find out over a period of time. You run simulation 100 times, probably somebody else is or someone is winning, right? So simulation models are basically used in casinos over a period of 1,000 or a period of say 1 million iterations or 1 lakh iterations, whether the casino will actually make the money, right? So now basically we have discussed about what are different computational models. We'll look at what is artificial intelligence. So this is one of the earlier definitions, the science of engineering of making intelligent machines, right? There is another definition, A is a branch of computer science, which deals with making computers do things at which at the moment humans are better. So the first definition is one of the earlier definitions from 1940s. And the second definition is actually from 80s, 90s. And artificial intelligence, basically the third definition talks about mimicking human behavior. So if you look at all these definitions, one common factor is there. It talks about intelligence. It talks about human, right? Intelligence. So basically it is all about building intelligent human systems that mimics human behavior. And AI should be designed to solve problems like decision making, object detection, and solving complex tasks. What are the different branches of AI? Machine learning, neural networks, robotics, expert system, fuzzy logic, and NLP. Is anybody working on any of these fields? All right. So when I was actually in college doing my engineering, one of the professors at that time actually gave us talk about fuzzy logic. So it was there since a very long time. And he talked about Japanese railway system using fuzzy logic to stop the trains within centimeters of the actual designated stopping area. So this was there since a very long time. And machine learning, we'll discuss. So machine learning is actually a subset of AI, and deep learning is actually a subset of machine learning. Robotics, I don't have to explain. You are very, very much familiar with it. And let's talk about natural language processing. Natural language processing is all about speech, vision, converting into, extracting information and making use of it. One example will be Siri or, Google. You can just speak to Google, right? So what happens is your voice is converted into text. The text is processed again. And when I started with AI, one of the first questions I have is, in both AI as well as in traditional programming or conventional programming, you write code. What is the exact difference? Can someone of you tell what might be the difference? All right. The difference actually lies in the approach that we take to solve the problems, right? Both of them are code, but the approach lies actually in the approach that we take to solve the problem. In traditional programming, what do? You write logic, you have rules, you have input, and you have output, right? And given any input, it is basically tailored for a particular task, right? So if it is simple as if you want to log into a system, you just log in, the task is completed. Whereas in AI, it is a little bit different, right? In AI, basically, it can actually learn from experience as well as it can learn from the data. That is the main difference between AI and traditional computing. Here you can see that in traditional computing, you have programmer actually writes the programs in the roles. You have the input, gives you the output. In AI, machine learning training process, you have training data, training expected output, right? Then you have computer that actually learns in the and behind the hood actually it learns. It creates an algorithm that or a model that you can actually use. So AI actually gives you a model that you can use, but in traditional programming you get the output. Let's look at one of the examples of an early AML system. It is actually called MySyn. So this MySyn was basically used to diagnose bacterial information. And how this was developed is basically the developer, entered a set of rules, and based on the rules, the diagnosis could be made, right? Question that you might ask is, how is it actually different from traditional programming, or how does it actually qualify to be an AI system? So this is the same question that I had, and what they were telling us, this particular program had automated reasoning and it had a decision-making process, right? It decided on its own whether it is, as per the earlier definition of AI, making computers do things at which at the moment humans are better. I think this qualifies to be an AI system because this system definitely might be a little bit better than a human. And if you're interested in algorithms, you can actually buy one of the books by Deepak Kamani. He's actually a professor at IIT. He talks about different search algorithms. One of the two of them I have picked up. One is actually state space search, and other one is actually heuristic search. So depth first search, if you have a tree to the bottom, I think all of you might be familiar with it. What is a depth first search? So basically, earlier AI, basically traditionally used to use these kind of algorithms, and heuristic search is again some best search as well as some claiming kind of algorithms. So let's look at what is actually machine learning. So machine learning is a technique to achieve AI. So ideally what it does is it receives data, it infers patterns in the data, and it creates a model, right? And using that model, you can dictate when a new input is coming, it can actually tell you, it can actually predict the output. So deep learning is basically a subset of machine learning, and deep learning drew inspiration from human neurons. On the top, you can see the diagram of a human neuron. So basically, our entire brain works on electricity, right? So what happens is this is actually the structure of a human neuron. So you have a nucleus, dendrites, axon, and axon terminals. There are other things also, but to simplify it for the purpose of neural networks, we'll have only so many relevant parts. So basically, nucleus, dendrites, axon. Dendrites receive input, axon, sends out the output. So how a human brain works is you receive several sets of inputs from using dendrites from different neurons. The dendrites are actually connected to different neurons, and axons are again connected to different sets of neurons. And what happens is the nucleus fires an output only once a threshold is reached. That means it does not fire all the time. Only once a certain threshold is reached, it will actually fire an output, and the signal is actually transmitted to our neurons. And the signal received from each neuron is different, right? And this is basically a mathematical model of a human neuron, where you have set of different inputs. You have a function that determines whether the output should be generated or not. And this is basically a neural network where you have the input layer, hidden layers, and you have an output layer. So I'll not get into details of types of deep learning. Basically, you have convolutional neural networks, basically used for image, video, recurrent neural networks, long short-term memory. So one of the things that I would like to talk about today is actually generative adversarial networks or GANs. How many of you have actually seen that website? This person does not exist. Please raise your hand. Okay, you've seen that website. So this person actually does not exist. It is a computer generated image, right? And if you're actually interested in, currently that website is not available. And if you're actually interested, you can actually go to GitHub and download StyleGAN or StyleGAN 2. It is pretty easy to set up. Again, just get it running on your machine and it'll just churn out images for you, right? So it was actually a application that model that was actually developed by NVIDIA. And how GAN actually works is it has a generator and it has a discriminator, right? So generator actually generates the image and discriminator tells that, okay, this is not a human at a very high level, right? So these are different types of deep learning techniques. I'm just leaving the keywords so that you can actually go back and explore. So how many of you actually thought AI looks like this? You have data, AI, and you have value. Please raise your hand. And under the hood, actually, AI is a little bit more complicated. You have data, you have to clean up the data, right? You have to decide on the models. And we'll discuss regarding that today. So this is actually a 7-step process to actually, solve a problem. The problem here is basically determine whether a drink is basically a beer or wine. How will you actually solve this problem? Could you please someone help me with the answer? Not using AI. Other than AI, how do you actually solve this problem? Exactly. So if you want to use a computer, how will you use it? How will you solve it? Color, of course, right? But is it guaranteed that actually it will give you the right solution, right? So these kind of problems, of course, you can actually build your own algorithms, try it out. But the better way of doing is really using, AML. So first process in any AML is basically collect as much data as possible. Then in this case, once you collect all the data, in this case, there is we can look at the amount of percentage of alcohol, sugar content, right? Acidity, color, the type of glass it is served, right? The next step is basically identify the features, right? What is important to your model. So in this case, we will decide to go with just 2 features. Glass, the problem is somebody can serve in a different glass, right? You can probably serve beer in a wine glass, right? So, I mean, it is an odd example, but finally you select this set of features, right? Features are nothing but attributes. In this case, we'll go with color and content, alcohol content, and actually color. Now, the next step is preparing the data. So in preparation of data, what we actually do is, in this case, to measure the color, use actually a spectrometer, right? In terms of wavelength, color is basically wavelength, and alcohol content in terms of percentage, right? So what you do is basically some values might be way off, so you have to clean up the data a little bit, right? Some values you might have errors in reading, so you have to clean up the data a little bit and try to visualize the data, right? Put it in a graph. So in this case, if you find that the number of samples you have for beer is say 80 and the number of samples you have for wine is just 20, right? Then your model will be little bit tilted in favor of beer. So you have to make sure that it is kind of balanced. So basically it is choosing the, basically it's just like preparing the data, right? And once you have all the data, you randomize it. You split the data into training data, right? And evaluation data. So a good percentage will be 80% for training and say 20% for evaluation. So training data is the data that you will actually use to train your model, and evaluation data is something that we'll use to check whether your model is working correctly, right? So if you're using the entire data for training, then it might not be the right approach. It might. Second step is actually using the right model. So in machine learning, there are actually two options. One is actually supervised and unsupervised. So in supervised learning, you provide the labels. Label is nothing but output. So in this case, you will tell that color, this alcoholic content, it is actually a beer, right? This color, this alcoholic content, it is a wine. So you are giving a label. Label means actually the output. We are telling this one in the data we have whether it is actually a beer or wine. You know the output, right? So there is actually one more method called unsupervised learning, right? And there are different models that computer scientists have actually, AI scientists have actually written. So like linear model is there. Then you have multilinear model, polynomial regression, decision trees, random forest. A lot of models are available. So you need to understand what these models are, right? To actually decide on what model you can actually use for your application. In this case, we'll actually use a linear model. So ideally, linear model is basically you plot your data on a plane that is actually two-dimensional plane, and you're actually trying to divide whether it is actually whether it is a wine or a beer based on a line. So linear model is all about basically in AI you actually divide things using a surface. In this case, we actually use a line since it is two-dimensional. So here the fact is, what is actually the formula of line? Y is equal to mx plus b, right? Y and x output and input, it is already frozen, right? It is part of our data. So only two variables are basically m, which is actually the slope, and b is basically y-intercept. Y-intercept means where it actually hit the y, where this line hit the y-axis. Now the purpose of AI is basically tuning. The purpose of a linear model will be actually to find a line that actually clearly separates wine and beer in this case, right? So you can have multiple features, right? So you have multiple lines, and in this case, what you do is you actually create a weight vector and a bias vector, right? So what happens is you provide the training data and you start with random values for W and D, right? Weights and bias. And we try to predict whether it is wine or beer. What happens for the first time? You have not done training, so the output will not be good. So what you do is actually you compare with the data you already have, right? First, you actually select a random value. You try to predict, you check whether it actually has given the right prediction. And you compare with actual values, but basically that is the training data, and you keep tweaking this. So ideally, you can see the line would have been horizontal in this case. You keep shifting the line so that there is actually a clear separation. The whole idea is actually fine tuning the value of W and B, keep on modifying the value of W and B, those two vectors, till you find a line that actually clearly separates wine and beer in this case. So the whole thing is the part that actually deals with finding those values, that is actually the most complicated problem in AML, which is basically called as an optimization, algorithms. So once you have fine-tuned the model and there is actually a clear separation, so finally what will happen is you will have a line here. So if this is wine and this is beer, you'll have a line here that clearly separates. wine and a beer, right? Now, basically, once you have a model, you have to try out that model, right? Basically, this is the evaluation. So you use the evaluation data and you give a new sample, you give a new one input, and you figure out whether it is actually able to make the right prediction. Another step in fine-tuning your model is basically parameter tuning. So a couple of options here I have listed. One is actually the learning rate, right? How much change would you allow, right, in each step? And the other one is basically how much time that we would actually spend in training, and how much time that, how many times that you have run using the same data, right? So basically the sixth step is parameter tuning, and the final step is basically prediction. Prediction is use a model in an application, you give the input, and it will actually predict whether it is actually beer or wine. So I think I have done justice to basically trying to explain what AI/ML is under the hood, right? So there are two streams in AI/ML. One is actually as a data engineer, and the other one is actually as a data scientist. Even if you want to be a data engineer, basically, which is building applications using services or models, right? It is still good to understand how it actually works behind, right? So it is really good to understand how actually these algorithms work. Or if you're a data scientist, definitely you are the people who actually create the models. Now let's look at the different services in Azure. In Azure, almost all the things that you want to do with AI. So if you are working for most of the companies, one example will be you want to convert from PDX to, extract data from PDF and actually create an Excel, right? You have a lot of PDFs, you want to extract the data. So you can actually use computer vision for that, right? So these are a different set of services that are available in Azure: cognitive service, machine learning, cognitive search, Azure Form Recognizer, Video Analyzer, Bricks, Databricks, Azure Streaming Analytics. So Databricks is basically for bringing in huge volumes of data, processing it. It is part of data engineering. Cognitive search is basically, I think you should try it out, right? If you provide a lot of data, it'll automatically do the search, those things for you and give you the output. Today we'll actually talk about, I am not going to explain this, but these are some of the services that are available in Azure. Infrastructure is there, AI services are there, some tools are also available. How much time do we have? 45 minutes. How much time do we have? 20 minutes. So if you want to try out this cognitive service, pretty easy, just sign up. It can be used for speech recognition, language understanding, and again, I've mentioned about search capabilities. Today, I have a demo on Azure Computer Vision. So Azure Computer Vision can be used for object detection, face recognition, and optical character recognition. And today, I will give a demo on OCR, right? How much time do you think? Have you done something related to AI, consume any services? If you have not done it, I will tell you that today you can try it out. Go home. By end of spend 2 hours, and you can have your first application that actually consumes AI. It's very easy to use. So I'll have a demo for. So this is basically a text. I would like to read some data from the text, right, using OCR. So this is basically the output. So we can see what I'm doing is, you had the text, you have seen the previous screen, right? I have some text, I have some, basically it is an image behind, and I have some text overlays. If I click on 200, you can see that, click on that parameter, if you click on 200, that value is coming there, right? Click on this one. So it's just a simple example that I have written just to show you how actually it works. How much time do you think it will take for you to actually build something like this? I mean, to write a program that can do this. Basically APIs, just pass in the information. So try this out today, right? So go to Azure portal, create a service, computer vision service. Then open that service, keys and endpoints, copy that key, right? And basically this is the only code that is actually required. 2 functions. This is all that is required to actually make your application OCR enabled, right? So if you can see, this is just nothing but a Ajax request where actually I'm passing the key as a header, and I have a callback function, right? So basically the callback function, in the callback function, what I have done is I'm checking whether the data is actually ready. So we have the data running in the background, right? The status is running, then again I'm calling the function again. Once the data is actually completed, I'm extracting the data, right? Once the data is extracted, you can use in whatever form you want. And this is actually the JSON output from an API. And you can see that here you have this particular component is actually one of the text from that that image. You have the bounding box information, and you have the text. Okay, it is actually the text is set gas. Yes.
Have a question.
Yes, please.
So this data, when we input our data, right?
You are inputting an image.
Image, right?
That's it.
So this image, when it gets converted into a text, whether the Azure is using that data to store internally as an enterprise, I'm thinking whether my customer data, when it is going.
You should be safe with that.
Yeah.
You don't have to worry about it.
So
You will not have to worry about it because millions of people are using Azure as a service. It should not be a problem.
it not be stored.
Unless the company policy mandates that this data should not go out of for whatever reason, right?
Yeah.
And even Department of Defense trust.
It's not stored.
Yeah, it is not stored. Your data is actually guaranteed to be protected by Microsoft. All right, let me actually show you. So basically, as you can see, it is pretty simple. Click on this, you can enter the value, unit value, pressure. Any questions? I think I'm done for today. Am I early?
I don't know.
Almost on time, I guess.
It's right time.
So you have any? Let me actually show you the code also. 1 second. Yet OCR, I have already explained this, but this is the core code. I think how many of you are going to try this today? Good. If you need any help, please feel to contact me. I'm available on LinkedIn. Definitely, I'll be available to help you.